We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour, so it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities. Nearly 12,900 years ago, hey, I wasn't around then, but something happened that pushed the northern hemisphere back toward the Ice Age. For years, scientists thought the cause was a huge asteroid, but new research points to something that was here on Earth all along. A volcano hidden beneath ice or underwater that, instead of melting the ice, did the opposite and made Greenland even colder. Scientists call this abrupt deep freeze the Younger Dryas. Despite how it feels with those unbearable summer heat waves around the world, Earth is still technically in an ice age. Earth's orbit and axis go through all kinds of tilting and wobbling, which is why we swing between colder glacial and warmer interglacial periods. Right now, we're in an interglacial period, named the Holocene. But before civilizations could really grow crops and enjoy summer, they had to endure this unexpected freeze that lasted for about 1,300 years. Evidence from Greenland suggests this change happened within just a few decades. Temperatures dropped by more than 27 degrees Fahrenheit, winds got stronger, and the entire North Atlantic started acting like someone turned the freezer up a few notches. In Europe's sediments, the plant record flipped back to cold climate tundra. That shift even brought back a tough little Arctic flower, Dryas, in the middle of Europe, and that's what this sudden, teeth-chattering cold spell was named after. But why the unexpected brrr? The clue comes from deep inside the Greenland ice sheet. All that endless ice is like the Earth's hard drive, with all the events sorted in order. When it snows in Greenland, the snow doesn't really melt away. Instead, more snow just keeps piling up on top of it each year. Over time, all that weight squashes the layers beneath, turning them into ice. This process captures tiny air bubbles that hold bits of the atmosphere. Basically, the frost keeps a snapshot of whatever was happening in the sky at that time. For example, if there was a big forest fire in Canada 5,000 years ago, the smoke and soot would drift over to Greenland and settle on the snow. If a big asteroid impact really happened around then, you'd expect its chemical traces to show up in the ice layers from that time. Now, to access this data, scientists use massive hollow drills. They drill deep into the ice and pull up long cylinders called ice cores. And because Greenland's ice is nearly 2 miles thick, those cores can preserve a ridiculously long climate record, allowing scientists to examine ice that's over 100,000 years old. By examining ice cores from that period, researchers found a sudden spike in platinum. This element is super rare near Earth's surface, but it's much more common in meteorites and asteroids. That's why theories were pointing to something huge from space. But how could an asteroid cause climate change? Well, basically, it works like this. Let's say a giant rock slams into an ice sheet. The impact blasts dust, ash, and all kinds of particles high into the sky, way above the clouds. Big booms can cause massive fires, adding even more smoke. Now the planet is wrapped in a dusty, smoky layer that blocks part of it back into space, which makes things colder again. That loop is called the ice albedo feedback. Sounds like a cool theory for the Younger Dryas. And just to make it even more tempting, Greenland also seems like it might be hiding the actual crater. Radar surveys beneath the Hiawatha Glacier revealed a round structure about 19 miles wide. Scientists were wondering if this was the one that caused the Younger Dryas, but dating showed it was about 58 million years too old to be the culprit. Also, a platinum spike doesn't automatically mean a meteor. Platinum from space usually comes with a supporting buddy metal called iridium. If you find one, you should find the other. But when scientists analyzed the Greenland ice, iridium was missing. So the chemistry didn't really point to a meteor. It looked more like volcanic magma from the North Atlantic. Then there's the shape of the platinum signal. It drains on for multiple years, not one sharp boom layer. It's more like something steadily feeding the atmosphere, not one big explosive impact. So, if platinum isn't pointing to a fresh impact, the next question is simple. What on Earth can put platinum into the sky and also cool the planet? The answer is a volcano. The kind they're talking about could have been in the North Atlantic region, possibly in Iceland, and it may not have even been fully on land. It could have erupted under thick ice, or underwater. Here's the difference. When a volcano blows its top in the open air, we get ash clouds and oozing lava rivers. But under the ice, magma hits meltwater, flashes it into steam, and can explode into fine ash and gas. Underwater, powerful eruptions can also fragment magma and push material upward. In both cases, the real trouble isn't the molten rock, it's the gas. Hey, I can relate. Now, big eruptions like these spit out massive amounts of sulfur dioxide. If that gas gets high enough, like miles above the clouds, it spreads out and mixes with water vapor to create sulfate aerosols. These are basically microscopic droplets of sulfuric acid. Individually, they're invisible, but get billions of them floating together and they act like a planetary shade. From space, Earth actually looks shinier because those droplets are reflecting sunlight. But down here on the ground, it's like looking at the sun through a thin, silvery veil. You don't need total darkness to freeze the world, you just need to dim the sun a little. Summers stop being truly warm, and snow survives into July. That leftover snow compacts into ice, which reflects even more sunlight. It's the same kind of feedback loop as the one triggered by an asteroid, except in that case, the sun is blocked by dust, while here, it's reflected back into space. Something similar happened quite recently. In 1991, Mount Pinatubo in the Philippines unloaded about 20 million tons of sulfur dioxide into the stratosphere. It wrapped Earth in a thin veil, and global temperatures dipped by about 1 degree Fahrenheit for about 2 years. Just imagine the scale of the eruption if Greenland's temperatures had dropped by more than 27 degrees Fahrenheit and stayed that cold for 1,200 years. But here's an interesting question. Could it be neither? Not a climate-changing asteroid, nor a hidden volcano. There's a third suspect that's much quieter but just as dangerous. Fresh water. One leading theory is that the world warmed up and a massive glacial lake in North America, often linked to Lake Agassiz, suddenly drained or rerouted, dumping an absurd amount, like quadrillions of gallons, of fresh water into the North Atlantic system. That fresh water diluted the surface ocean in regions where dense, salty water normally sinks and helps drive large-scale Atlantic circulation. When that sinking weakens, the overall circulation slows down and less ocean heat reaches the North Atlantic. With that system disrupted, the Northern Hemisphere could cool extremely fast on a climate timescale, within years to decades rather than centuries. In that version, the platinum spike could be a coincidence, a volcanic burp during the freeze, not the trigger. And in the end, if the volcano was the cause of the endless winter, could this happen again in our time? Absolutely. The North Atlantic region is still geologically active. Iceland erupts regularly, and the volcanic systems along the Mid-Atlantic Ridge are very much alive. But it wouldn't be a jump scare out of nowhere. Even volcanoes buried under the ice usually give warnings, like earthquakes. If heat builds down there, it can melt large volumes of ice from below before anyone sees ash in the sky. On the other hand, it wouldn't need to be a planet-destroying eruption. A moderate blast that injects sulfur high into the stratosphere could dim sunlight for a couple of years, just like Pinatubo did. That does not mean a new ice age will start the day after. Today's climate background is very different from 12,800 years ago. But the mechanism is real. The atmosphere can still be nudged, and sometimes all it takes is a hidden eruption. Astronomers just spotted an asteroid roughly the size of 8 football fields. It spins so fast that it completes a full rotation in just under 2 minutes, which makes it the fastest asteroid ever found in its size class. If this bad boy hits Earth, the consequences will be, well, let's just say everyone will notice. You think? Scientists caught MN45 using early data from an observatory on a mountaintop in Chile with a 3,200 megapixel camera. Ooh. It will be scanning huge areas again and again for 10 years to catch what moves, what flashes, and what wasn't there yesterday. The SuperCam takes an image every 40 seconds, and that's how it noticed MN45. The same equipment recently caught around 2,000 other asteroids, but our hero definitely stands out. Now, an asteroid spinning this fast probably didn't start life as a calm, normal space rock. Scientists think a past collision could have smacked it hard enough to spin it up like a toy top. And if that impact was violent enough, MN45 might not even be the original asteroid, but a fragment that broke off from a much larger parent object. Basically a piece of a bigger monster that got shattered long ago. Spinning fast in space isn't just a flex, it's dangerous, because rotation creates stress, and stress tries to rip an asteroid apart. If a space rock doesn't have enough internal strength, it doesn't stay one object. It fragments into smaller pieces like a cookie that cracks when you twist it too hard. That's why most asteroids never spin this fast. Most of them aren't solid boulders. They're rubble piles, basically space gravel held together by weak gravity, like a floating clump of broken rocks. Astronomers have a kind of speed limit for asteroids. In the main asteroid belt between Mars and Jupiter, a typical rubble pile asteroid needs to rotate more slowly than about 2.2 hours per full spin to stay intact. Anything faster than that starts entering the danger zone. So if an asteroid spins faster than this limit, and it's still big, that's a massive clue. It must have unusually strong material inside, like solid rock or something even denser. Because if it were weak and crumbly, like most asteroids, it wouldn't be spinning. It would already be a cloud of debris. The good news is that this hard rock asteroid isn't coming for Earth. It's at a safe distance from us, up in the asteroid belt. But its existence screams something terrifying. If something this big and this extreme stayed unnoticed until now, what else could be hiding out there? Perhaps the real threat isn't one record-breaking spinner, but a blind spot. Some simulations show that there could be a whole swarm of hidden city-killer asteroids hanging around Venus like cosmic pickpockets. As you can guess from the name, these asteroids are large enough to destroy an entire city. The reason they're so hard to catch is that they hide in sunlight. From Earth, the area close to the Sun looks bright and washed out, which makes it easy for objects near Venus's orbit to blend into the glare. It's like trying to spot a black cat in a dark room when someone shines a flashlight straight into your eyes. And this is where it gets personal, because humans love pretending we control space. But these Venus-hiding asteroids don't care. Their orbits can shift slowly over time because of gravity nudges and long-term motion. And that means one of them could eventually get pushed onto an Earth-crossing path. Not today, not tomorrow, but someday. And in asteroid terms, someday always arrives faster than people expect. Now let's talk about a completely different kind of dangerous asteroid, Bennu. Now Bennu isn't a solid rock freak like MN45. Bennu is a rubble pile, a loose, clumpy near-Earth asteroid about 1,600 feet wide. It's famous because NASA actually went there. The OSIRIS-REx mission grabbed samples and brought them back to Earth. And what scientists found inside was straight-up mind-blowing. There were life-linked elements, including sugars like ribose and glucose, plus a weird gum-like organic material, and even ancient stardust. Down on Earth, ribose helps build RNA, and deoxyribose helps build DNA. DNA and RNA are basically life's instruction manuals. They store information the way a hard drive stores files. But before you get too excited, no, finding these sugars on Bennu doesn't mean it had life. But it does mean the building blocks needed to build biology weren't rare or special. They were everywhere, floating around in the early solar system. Scientists have already found ribose before in 2 meteorites that landed on Earth, so it's not totally unusual. All that is cool and totally benign, but Bennu has a scary side too. It isn't likely to hit Earth, but researchers still model it because it has a very small chance of impact in the late 2100s, including around 2182. And if Bennu hit, it wouldn't wipe out dinosaurs again, but it could wreck climate patterns, blast huge regions, and trigger global-level effects, depending on where it struck. Bennu is like the perfect reminder that space can carry both the ingredients of life and the power to erase it. And if you want more reminders like this, space is like a gallery of cool asteroids. Take Ceres, for example, which was first classified as a planet, then demoted to an asteroid, and then promoted to a dwarf planet again. Hey, talk about an identity crisis. One thing is for sure, it's basically the boss of the main asteroid belt between Mars and Jupiter. No matter what label you slap on it, Ceres is a cold ball of rock and ice about 600 miles wide. Living there would feel like surviving on hard mode. Ceres has no substantial atmosphere, so you need a spacesuit just to breathe and to avoid freezing. Daytime temperatures range from about -136 to -28 degrees Fahrenheit, and at night it drops to around -225. But you'd also feel ridiculously light, because Ceres' gravity is only about 3% of Earth's. A 150-pound person would feel like 4.5 pounds there. Ceres is like a failed planet, leftover rubble from the solar system forming, a proto-planet that never fully grew up. NASA's Dawn spacecraft went to see it in 2015 and spotted bright white patches that looked like headlights from some strange spaceships. The biggest one sat inside a massive crater. Scientists thought it might be exposed ice, but it turned out to be sodium carbonate, salty mineral leftovers from briny water that bubbled up and vanished into space. Even crazier, that salty water may still come from a reservoir about 25 miles below the surface, and the activity could still be happening today. Life seems unlikely there, but with water involved, it might have existed in the past. Now this guy, Tutatis, another cool asteroid, has a weird double-lobed dumbbell shape. Instead of smooth spinning, it does this chaotic tumbling motion, like someone tossed a wrench into space and it never stopped flipping over. Scientists think part of the reason for this weird movement is that Tuditus might be two bodies barely touching. That makes it unstable right away. Then gravity shows up and makes it worse. As Tuditus travels through the solar system, the gravitational pull of Earth and even Jupiter can tug on it, messing with its rotation like invisible hands turning it at random. That's what makes it so unpredictable. It's not just spinning, but constantly getting nudged into new motion patterns. The path it takes through space brings it close to Earth, which sounds terrifying, but the even scarier part is the word chaotic. Scientists determine its orbit for the next few centuries, and it won't collide with Earth in the next 6 centuries. But we don't know what can happen after that. So, as you can see, we don't need to be afraid of every asteroid scientists have spotted, but we might have a good reason to fear the ones they haven't seen yet.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a supereruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises. Could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.
It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers in telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, very few people knew that the sun was to blame for the chaos. One of them was English astronomer Richard Carrington. At about 11 a.m. on September 1st, the man was standing by a telescope in his private observatory. He was watching sunspots on the surface of the sun. Suddenly, two patches of intense white light broke out. They looked as bright as direct sunlight. At that moment, the astronomer didn't know what a terrible commotion these flares would cause. Later, it became clear that the sun had produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Wave after wave of charged particles slammed into Earth's atmosphere. The planet's magnetic field wasn't powerful enough to stop them. It gave way, and the storm hit Earth, causing havoc. The phenomenon got the name of the Carrington event. So far, it's been the worst solar storm ever recorded. Good thing it happened when people didn't have advanced technologies and weren't that vulnerable to the sun's geomagnetic fury. The 1859 solar storm was 3 times more powerful than the one that happened on March 13, 1989. 3 days before it began, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. Millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the US, hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, but in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, a year. No light, no computers, no phones. Water supply systems out of order, no food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares. But while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problem for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the Sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean's surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the sun's surface. The corona of the sun is much hotter than the surface of the sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the sun. Cool, huh? Turns out the sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the sun. Now that the sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So, there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress is accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
You look out the window and see the trees moving uncontrollably. The winds are so powerful, they're practically tearing down anything in the street. There are also tons of water raining down on you. You're driving as fast as you can, but suddenly your car stops. You've heard the terms typhoon, cyclone, and hurricane, but you most likely don't know how they're different. The official scientific term for all three of them is a tropical storm. While they're practically the same thing, and they form the same way, they're different depending on where they occur. Hurricanes are the ones that form over the Atlantic Ocean or the Eastern Pacific Ocean. Tropical cyclones act as giant engine turbines powered by warm, moist air and form only over warm bodies of ocean water near the equator. The warm and moist air surrounding the ocean rises and leaves low-pressure air close to the surface. In turn, the air below becomes moist and warm and also rises. The cycle goes on, with warm air pushing up and squeezing the low pressure near the surface, only to rise as warm, moist air. When the warm, moist air cools off, it forms clouds. These clouds create the tropical storms we all fear. The storms spin the same way as the Earth is rotating. So, storms to the south of the equator rotate clockwise, and storms north of the equator spin counterclockwise. The eye of the storm happens when the storm spins so fast that it actually becomes visibly clear in the center with low air pressure. But you'd have to look at it from above, which is super risky. Tropical storms normally move at around 39 miles per hour. Tropical cyclones are way faster, around 74 miles per hour. They're also known as hurricanes. If you're standing at the tip of the North or South Pole, the Earth's rotation will appear to stand still, even though the rest of the Earth is experiencing day and night like everyone else. In the poles, you have really long nights and days that last for months. Over at the equator, time moves along with the distance around the planet, which is around 25,000 miles long. The Coriolis effect makes wind patterns traveling long distances around Earth appear to move in a curve rather than a straight line. And because of the planet's unique shape, the speeds are different. It affects the Coriolis force and hurricanes as well. Because there's no curving of the object's path as measured relative to Earth's surface at the equator, the Coriolis force equals 0. A hurricane starter pack includes deep, warm ocean water. It all happens in the moist middle layers of the atmosphere, with a chilly atmosphere on top. It also takes some low wind and some surface disturbance. And it can stretch around 300 miles away from a large body of water where the center of a large hurricane is. The good thing is that hurricanes get weaker when they hit the land, because the warm water in the middle of the ocean isn't giving it the juice it needs to stay pumped. But it'll still carry a sustainable amount of damage with the strong winds and rain. In 1900, one of the biggest hurricanes struck near Central America and in the Gulf of Mexico. It then went as far as Florida and Texas, and is considered to be the most devastating hurricane in the United States' history. They first detected it on August 27th, and it lasted for many days. By the time it reached the Texas coast, the storm had turned into a Category 4 hurricane. Hurricanes are categorized on wind speed and intensity, using something called a Saffir-Simpson scale. There are 5 different categories from 1 to 5, with 1 being the weakest and 5 being the strongest. A Category 1 storm has winds moving at between 74 to 95 miles per hour. You can expect some trees to be uprooted and mobile homes destroyed. It can take out some home exterior and cause major power outages. Category 5 hurricanes speed up to over 155 miles per hour and leave nothing in their path. They can even wipe out some buildings right off their foundation. And because the winds are faster, there is more damage around its radius. Another thing to expect is lots and lots of flooding. The people of Galveston had less than 4 days to prepare for the arriving storm that even stretched out to Oklahoma and Kansas with 20-foot flash floods. The Great Hurricane then made its way to the Great Plains and turned towards the Great Lakes, New England, and reached southeastern Canada. The storm was so bad that more than 3,600 homes were damaged, even though they were sturdy enough to withstand the storm. Given the population numbers back then, it was equivalent to hundreds of thousands of houses destroyed, if not millions. The total property damage was around $30 million then, which would be a lot more now because of inflation. After the devastating storm, the people of Galveston built a 3.5-mile seawall and raised the whole city level by as much as 16 feet. Eventually, they raised the seawalls to 10 miles, just in case. If a storm like the one in Galveston struck in modern times, there wouldn't be enough places for everyone to hide. The population has increased significantly all over the areas where the storm struck back in 1900. So, imagine yourself sitting in your car and getting the breaking news. It says a storm has just hit the Gulf of Mexico and east of it near Cuba. No biggie, since you're all the way in Texas. So you drive back home. There's plenty of people at gas stations and in supermarkets. The news now states that the storm will likely gain momentum and strike right where you live. Okay, now it's time to panic. You want to get some stuff to prepare for the incoming storm, but all the shelves are empty by now. Everyone is pushing and shoving like at a rock concert. You grab whatever you can find and make your way back to your car. You're lucky enough to purchase some extra gallons of gasoline, just in case. You drive from supermarket to supermarket to try and get some stuff, but you're out of luck. Finally, you find a place that still has some essentials. You start stocking up your shopping cart when the local news urges everyone to evacuate. You only have a matter of hours to leave. But you left your dog at home! You rush against the traffic to get there. Your entire neighborhood is completely empty. You fetch your precious pooch and grab some important things before leaving. There's just a little time left, and you can already start to feel the winds picking up and the ocean nearby. The news tells you the hurricane has already struck Florida. You get in the car, but it won't start. Since you were driving so fast, you didn't realize that you emptied your gas. Good thing you got those extra gas cans on the way. With half a tank, you can get out of your city and into a safe place where everyone is going. The winds are getting stronger. There's no way you're going to outrun this storm. There's no one in sight since they all left early. It starts raining heavily. You can see some trees swaying like crazy. Finally, you find something that looks like a large shelter. You reach it to find out that it's just an abandoned mall. And then, the worst happens. You realize you've been going in the wrong direction all this time. You get out of the car for a bit to stretch out and see which road to take. The winds are so strong that you go back to the car only to find out that your dog ran off. You can't find her anywhere. You drive around and call out her name, but she doesn't respond. You see her standing behind some bushes barking. You run down to her and discover that she has found a cool underground abandoned shelter. The winds have now reached a dangerous point where you can't drive anymore. You gather your stuff and head down. It's complete with everything and even has a bed. You can hear the winds and rain above you, but you're snuggled up with your dog. The next day, you get up and see that your car has been tossed over to another road, and there's not a single tree in sight. But hey, you can at least be happy you survived one of the strongest storms in the world.
This is John. John seems to attract all kinds of bad weather and natural disasters wherever he goes. See for yourself. One day, John notices his dog is restless. The pooch keeps scratching the entrance door and wandering around the house. He even tries to hide in the corner, howling and barking. When some mugs start to clink in your cupboard, John realizes what it means. The noise is produced by foreshocks, mini earthquakes leading up to the main event. Earthquakes often happen in clusters. After a few weak quakes, a much bigger one is likely to be on the way. Sometime before the disaster strikes, people might notice bizarre blue lights. Some of them seem to be coming out of the ground. Others are hovering in the air. These are earthquake lights. They may appear days or mere seconds before the ground starts shaking. Now, John is walking along the ocean shore. Suddenly, he sees the water retreat from the beach. Really, really fast. Uh-oh. John, run away as quickly as you can and find some high ground. A tsunami is coming. And your life might depend on how fast you react. If John spots a bizarre and unexpected rise in sea level, it can be another sign of an approaching tsunami. This happens in 40% of cases. The incoming water is the first tsunami wave. The second one, way larger, will come in about 10 minutes. John can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. John feels there's something strange about the sun. Through his special super dark sunglasses, he sees that there's some uneven flares around the star's contour. If these bizarre rays are accompanied by auroras all over the world, they're a sign of a solar storm. Such storms are usually caused by disturbances in the sun's magnetic field. In this case, the bursts of gas and radiation on the surface of the sun get so massive and powerful that they can even reach our planet. Luckily, solar storms aren't really dangerous for people, but they can mess with electricity and even cause blackouts. The sky over John's head is darkening and turning ominously green. Something hits him on the forehead. Ouch! He picks up the offending object. It's a hailstone, but it's not that cold outside, and it's not raining. Soon, he hears some noise. It's approaching rapidly and turns into a loud roar. It sounds as if a freight train is moving towards him, but it's not a train. It's a tornado. The funnel isn't visible behind a cloud of debris, but John can't mistake this rotating column of air for anything else. Are you on the road, John? Then get as far away from your car as you can. Fast! Find a ditch, lie down in it, and cover your head. Oh, you're inside? Then get away from the windows and hide underground if possible. And please, John, be very careful if you spot some conically shaped clouds. Those mean severe storms. And if you notice that such a cloud starts spinning around, immediately search for shelter. The cloud is transitioning into a tornado right in front of your eyes. On the bright side, John should only worry about warm conical clouds. Cold ones are totally harmless. The only problem is to figure out the temperature of the cloud he sees. Duh! Ah, look, John just spotted some weirdly shaped trees. They look like the letter J and grow on a slope. It means the ground under John's feet is likely to be unstable. If he keeps wandering around, it can cause a bad landslide. Square waves appear when two different wave patterns crash into each other. This phenomenon does look kinda awesome. No, don't go into the water, John. Keep watching it from the shore. Cross currents in that spot can easily pull even a skilled swimmer under the surface. John keeps walking along the shore. At one point, he sees wild, choppy waves carrying ocean debris and seaweed. This time, he stays out of the water. He knows it can be a sign of a strong rip current. It can carry a swimmer far away into the ocean. How about a walk in the park? John likes this idea. The sun is shining and the sky is so blue and beautiful. Suddenly, he spots a rapidly growing vertical cloud. At first, it looks bright white. But as it approaches, alarmingly fast, it becomes dense and inky. The sky is darkening. It's getting windy. That's when the guy notices that his hair stands on end. It's his cue that he's about to get hit by lightning. At this very moment, positive charges are rising through his body. They're reaching towards the negatively charged part of the storm. If he doesn't react fast, these charges will meet. There's nowhere to hide, so John should crouch down and try to make himself smaller than the objects around him. Oh no, John, don't lie down on the ground. It may be damp and thus a great conductor of electricity. There are other signs that scream danger during a lightning storm. John's palms may begin to sweat. He might hear bizarre crackling and buzzing sounds coming from metal objects nearby. His skin can start tingling. There might be a strange metallic taste in his mouth. Plus, John is likely to smell chlorine. That's how ozone smells. Electrical charges split the molecules of nitrogen and oxygen, which are the main gases making up the atmosphere, into separate atoms. When these atoms come together again, some of them produce molecules made up of 3 oxygen atoms. That's ozone. We can smell it during a thunderstorm because downdrafts bring this gas from high altitudes to your level. Some bugs can feel a storm coming. They get ready for a natural disaster by freezing. So, when John notices that insects around him look drowsy, he knows to get ready. Oh, and bees can predict heavy rainstorms. These critters begin to work much harder the day before it starts raining. While walking next to the river during a period of heavy rains, John hears a roaring sound. He feels paralyzed with fear. It's likely to be a flash flood moving in his direction. Indeed, he soon sees debris coming down with the flow. The water is rapidly changing its color, becoming muddier and darker. Flash floods are very, very dangerous. Take care of your safety immediately, John. Another day, John sees a spectacular wall cloud. It seems to be stretching for up to 5 miles. In the best case scenario, it's just a severe storm coming. But if the wall cloud begins to move in a circle, it's a sure sign of a tornado. John is walking across a snowfield in the mountains, listening to the sounds the ice under his feet makes. The noise is kinda hollow. Quickly check whether there are cracks around your footprints, John. If so, the chances are an avalanche is about to happen. Soon, John sees an avalanche moving in his direction. He does his best to get off the slope. In most cases, he could probably outrun it by heading downhill and then veering sideways, but not this time. He realizes he doesn't have enough time and heads for the nearest tree. If John keeps holding on to it really tightly, the avalanche might not pull him along. But if this doesn't work, he should try to swim up to the snow's surface while the avalanche is still moving. On a pretty nice summer evening, John notices leaves with soft stems droop all of a sudden. It might be because of an upcoming storm. Right before extreme weather arrives, the air usually becomes more humid. Leaves also get damp and heavy, and the wind easily flips them over. John lives in a pretty old house and is used to having cracks in the interior walls, but one day, he notices that some of them have widened. And look, there are a few new ones. It's an alarm bell. He lives in an area with loads of limestone, so new cracks can mean a sinkhole is about to open next to his house. John is hurrying home, trying not to waste time admiring shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft, and these ominous clouds most often mean a storm is coming. Take a look at Australia from space. Nothing unusual, right? But now, focus on the northern territory of the continent. If we imagine it through magnetic sensors, we notice, whoa, see that? An unknown strange thing that mirrors the outline of Australia itself. It looks almost the same, but smaller. It's like a twin of the continent hidden deep within it. But what is it? Volcanic lakes? Gold deposits? No, it's something far stranger. This is a magnetic anomaly. Yeah, you're probably confused, but let's find out what's going on with Australia. So, there are devices called magnetometers. They measure magnetic fields, and geologists use them for many things, including exploring the interior of our planet. The magnetic field comes from various metals and minerals buried deep underground. It travels upwards, and scientists' sensors detect it. One day, they equipped aircraft with these magnetometers and flew over the northern part of Australia. When they processed the data and identified a magnetic anomaly with clear geological boundaries, whatever lay in Australia's interior was emitting magnetic signals and followed the outline of the entire continent. And because these signals come from deep rocks, scientists think that valuable resources, including minerals and metals, might be hidden there. But beyond potential resources, what else does this tell us? Inside these rocks, there could be volcanic materials formed over 1.5 billion years ago, minerals that formed long before the dinosaurs appeared. This entire mass of material could tell scientists about our planet's history and how the Australian continent was formed. Okay, that sounds cool, but why are those changes in the magnetic field they detected called an anomaly? Why is it magnetic in the first place? And how does this magnetism work? To understand, we first need to grasp what Earth's magnetic field is. And this is one of the most amazing and mysterious things in the world. The magnetic field is invisible, yet without it, we couldn't exist. So, in simple terms, Earth's magnetic field is our protective blanket, shielding us from cosmic radiation, charged solar particles, and the solar wind. Without the magnetic field, our Earth would be like Mars, a barren desert where life most likely couldn't have emerged. But where does it come from? The magnetic field is generated deep within our planet, where molten nickel and iron create electrical currents. Combined with our planet's rotation, these electrical flows generate the magnetic field that protects us. In addition, minerals and metals inside rocks can produce magnetic fields too. But what exactly is this force? Take two magnets from your fridge and try to push them together. Feel that resistance? That repulsion happens because their magnetic fields are interacting. In some places, this magnetic field can be weaker, and in others, stronger. This means that deep within the planet, in those locations, there are geological processes happening that change the stable behavior of the magnetic field. These places are what we call magnetic anomalies. One of them lies beneath the northern part of Australia. However, the magnetic field is more than just a blanket. Thanks to it, many awesome things happen. For example, a compass needle always points north because the Earth's south magnetic pole is located there, attracting the magnet. Don't confuse the geographic and magnetic poles. The geographic North Pole is in the north, near the magnetic South Pole. It's not just humans who use the magnetic field for navigation. Animals can do it too, without any instruments or technology. Some animals sense the magnetic field, and this superpower is called magnetoreception. This ability helps animals during migration. That is, they know where north and south are. So when it gets cold, they can fly to where it's warm. For some turtles, magnetoreception helps them remember the location of feeding areas. Pigeons have a unique perception of the magnetic field too. In simple words, the magnetic field is also a giant navigation system for many creatures on Earth. Few people know, but we actually have a second magnetic field. In 2018, scientists published research describing how ocean tides create another magnetic layer. But why hadn't we noticed it before? Our main magnetic field, generated by the planet's core, is very strong. Its radiation extends into space and is easy to detect. The magnetic field from tides is almost 20,000 times weaker. How does this field affect the main one? What are its properties? Scientists continue to study these questions. Also, the magnetic field can control the brain. In 2017, scientists used magnetic fields to remotely activate brain cells in mice. Magnetic forces were directed at the parts of the mouse brain responsible for body movement. In this way, the scientists could make the rodent run, freeze, and turn around. But don't think this was done just for fun. Experiments like this can be very helpful for humanity. If you can make a small animal move, imagine what other changes might be possible in the brain. Improving psychological state, for example. Potentially, you could instantly switch from a bad, depressive mood to a happy one. This technology could help treat many diseases related to the brain and nervous system. You might think that such a technology could control you, but don't worry. Magnetic fields pass through your tissues with almost no effect. But then, how did they manage to control those mice? Scientists simply implanted tiny magnetic particles into the animals' brains. Under the influence of a magnetic field, these particles heated up and triggered the activation of neurons. But the coolest thing happens when the magnetic field collides with the solar wind, generating electrical currents and magnetic forces. At the moment, a true cosmic storm happens in the sky, and we see it in the form of beautiful auroras. Such storms are not only beautiful, but also destructive, as they can disrupt the operation of satellites and electronic devices. Sometimes this can lead to minor glitches in your GPS or internet connection on your phone. But there have been cases where magnetic storms were so massive, they led to catastrophic consequences. One of them occurred in 1859 and is known as the Carrington event. On September 1, 1859, an amateur sky watcher, Richard Carrington, noticed a sudden bright white flash on the sun. It turned out this flash was a massive ejection of plasma from the sun's upper atmosphere. About 17 hours later, part of this energy reached our planet and struck as a powerful storm. All telegraph systems at the time went down. The northern lights were visible not only to residents of northern regions, but also in the tropics. For many people who had never heard of or seen the northern lights, this was a real surprise. What must they have thought? The end of the world? Unknown forces from space? Many were undoubtedly shocked by the spectacle, but the real shock was inside major cities. Communication between telegraph systems was stopped. The world was plunged into an eerie silence. Sparks flew from telegraph machines, causing fires in some places. People couldn't send or receive important information. Fortunately, the consequences weren't too catastrophic. Communication technologies were just beginning to develop at that time. But what would happen if such an event occurred today? Many experts have estimated that the damage from a similar storm in the United States could reach up to $2.6 trillion. The entire internet would shut down. For a while, we would lose access to our messaging apps, our banks, our navigation systems. Contactless payments, airports, train stations, and much more would stop working. We would be cut off not only from the internet, but also from electricity for a long time. The entire planet would be plunged into darkness and silence. A global economic and humanitarian crisis would begin. It's hard to imagine the damage that AI would suffer. But don't worry, the good news is that storms like this happen roughly once every 500 years, and smaller ones about every 50 years. But these aren't precise forecasts, since it's quite difficult for scientists to predict the sun's behavior. Besides, we wouldn't just sit in shock after such an event, we would immediately begin dealing with the consequences. The impact on modern civilization from such a storm would be significant, but we would surely recover quickly. The United States didn't neatly grow into 50 states. The map we see today is more like the result of a lot of attempts, negotiations, and a surprising number of ideas that almost worked but didn't quite make it. At different moments in history, entire regions, like parts of North Carolina and Tennessee, tried to split off and become states of their own, and some of them, like Delmarva Peninsula, came very close. Part of the reason is how the system itself is built. States can shape their own rules on things like taxes, schools, business regulations, and even parts of criminal law. So everyday life in California can feel very different from life in Ohio. But they're still tied together under one national framework. There's one constitution, one overarching set of rules that all states have to follow. What really drives these breakaway ideas is something simpler: people feeling overlooked. In a country this large, some regions start to feel like decisions are being made far away by people who don't really understand their situation. Over time, that frustration turns into a question: what if we just handled things ourselves? So here are 12 places that tried. Start with Scott in northeast Tennessee. In 1861, when Tennessee chose to side with the Confederacy, Scott County pushed back. Locals didn't agree with that direction, so they declared themselves the free and independent state of Scott and stayed aligned with the Union. No one formally recognized it, but what's interesting is how long the idea stuck. Scott County never officially reversed that decision until 1986. For over a century, it quietly carried this identity, almost like a historical footnote that never got erased. Now go north to Michigan and the idea of Superior. Michigan looks simple on a map until you notice it's split into two separate landmasses. The Upper Peninsula sits far from the main population centers and developed a different identity, more focused on mining and forestry, less connected to the urban South. That gap led to repeated calls for a split, basically a divorce between the two halves. The idea goes back to 1858 and has resurfaced many times. In 1959, someone even filed a lawsuit to try to make the separation official. It didn't succeed, but the fact that it reached that level says a lot. Even today, you'll still hear occasional talk about it. Out west, there's Lincoln. This one keeps reappearing in different forms. The general idea is to combine eastern Washington and northern Idaho into a new state. It first showed up around 1865 when people in northern Idaho felt cut off after the capital moved further south. Since then, the idea has come back again and again. In 1901, the 1920s, and even as recently as 2005. Each time, the reasoning is similar. Rural inland communities feeling disconnected from coastal or urban centers like Seattle. A bit further south, you get Jefferson, which is almost a mirror version of Lincoln. It would combine Northern California and Southern Oregon. The idea dates back to the 1850s during the gold rush, when remote communities wanted more local control. The most dramatic moment came in 1941. Supporters staged a kind of theatrical protest, blocking highways and handing out declarations of independence. It caught attention, but then global events shifted focus overnight and the movement faded. Decades later, in 2013, several counties in California voted to explore the idea again. Nothing changed officially, but the identity of Jefferson still exists and even has its own flag. Then there's Absaroka in the late 1930s, covering parts of Wyoming, Montana, and South Dakota. This one grew out of the Great Depression. Rural communities felt like they weren't getting enough support compared to larger towns. A local official, A.R. Swickard, stepped forward as a leader and started acting like the head of a new state. They created license plates, held public meetings, and even crowned a Miss Absaroka. It sounds unusual, but it worked as a signal. Attention increased, resources followed, and once conditions improved, the movement faded away. Now compare that to Sequoia, which was far more structured. In 1905, several Native American nations in what is now eastern Oklahoma proposed forming their own state. Their goal was to maintain control over their land and systems. They organized a full constitutional convention, drew up laws, mapped out counties, and held a vote that strongly supported the plan. It was one of the most complete statehood proposals ever made, but Congress turned it down, mainly to avoid shifting the political balance. Instead, the area was merged into Oklahoma in 1907. Even so, the work done for Sequoia ended up shaping Oklahoma's final structure in lasting ways. On the East Coast, Delmarva nearly became real in 1833. The Delmarva Peninsula is split between Delaware, Maryland, and Virginia, but it feels like one continuous region. Delaware proposed unifying it into a single state. Maryland seriously considered the idea and even discussed letting residents decide. Most signs pointed toward approval, but when the final vote came, it failed by a single vote, 5-4. That was it. The vote decided that Delmarva would stay divided. It's probably one of the clearest, almost happened moments on this list. Back to the Civil War period, there's Nickajack. This proposed state would have covered parts of eastern Tennessee and northern Alabama. The region's terrain didn't favor large plantation agriculture, so, for obvious reasons, many residents didn't support the Confederacy. When their states aligned with it, locals tried to break away and remain aligned with the Union, similar to what West Virginia managed to do. But the political structure worked against them, and the plan never moved forward. Even so, many people in the region still chose to support the Union individually, showing how divided things were locally. Then you get Deseret, one of the most ambitious ideas on the list. In 1849, Mormon settlers proposed a massive new state centered in present-day Utah. It would have included large parts of what are now several western states. They didn't wait for approval. They wrote a constitution, set up leadership, and ran their own system for about 2 years. The proposal was simply too large and too complicated for Congress to accept. Instead, a smaller Utah territory was created in 1850. Still, the idea of Deseret didn't disappear immediately. It continued quietly in the background for years, almost like a parallel vision of what the region could have been. Next is Franklin, an early and surprisingly advanced attempt. In 1784, settlers in what is now eastern Tennessee felt abandoned after a confusing land situation. So they created their own state. They had a capital, a legislature, courts, and leadership under John Sevier. They even applied to become the 14th state, but fell just short of the required votes. For a few years, Franklin operated alongside North Carolina, almost like two parallel systems in the same place. Eventually, support faded, and the region was brought back under North Carolina's control, but not before proving how far a determined group could go. Even earlier, in 1776, there was Westlvania. This proposal covered parts of modern West Virginia and western Pennsylvania. At the time, it wasn't even clear which colony controlled the area. Settlers felt stuck between distant authorities and wanted a system closer to home. They asked Congress to recognize them as a new state. Congress ignored the request, and once the border dispute between Virginia and Pennsylvania was settled, the idea lost momentum quickly. Without that uncertainty, the push for independence no longer had the same energy. And finally, Transylvania. Despite the name, it has nothing to do with Dracula. In 1775, a land company led by Richard Henderson bought territory from the Cherokee and tried to establish a new colony in what is now Kentucky and Tennessee. But the deal broke British rules about land ownership. Before anything could fully develop, Virginia stepped in, canceled the agreement, and took control of the land. It's one of the earliest examples of how complicated land claims were in early America. If you zoom out a bit, a pattern starts to show. A lot of these places were on the edges, far from where decisions were made, harder to reach, with their own way of life. And here's something you might have noticed. Tennessee keeps popping up. 4 out of these 12 lost states were connected to it in some way.
You're sailing on a calm ocean when you see it, a giant wave rising out of the water, towering over your boat. Uh-oh. But before you can react, the deck suddenly disappears beneath your feet, and you're falling into a deep and vast pit in the sea. Neither outcome gives you a chance to survive. Apparently, the ocean can both crash down on you and suddenly drop away beneath your feet. It's not your day. Well, in the first case, it will be a giant rogue wave. These waves are huge and dangerous ocean waves that appear suddenly and are at least twice as tall as the waves around them. These waves can rise up in the open ocean without warning and may move in a different direction than the wind and other waves. They're extremely dangerous, even for big ships, because they form super quickly and grow to be exceptionally large. But there's even a scarier threat in the ocean: rogue holes. Those are massive pits in the water, and until recently, no one could confirm their existence. They are the opposite of rogue waves. Instead of a huge wave rising up, they are deep dips in the ocean that appear suddenly, sometimes just before or after a big wave. The water drops sharply, often surrounded by normal-sized waves on either side. When the difference between the top of the waves and the bottom of the dip is much bigger than normal, it can be just as dangerous for ships as a giant 80 to 100-foot wave. Now, scientists have figured out that big waves and deep dips often happen together, so the danger they present now doubles. ESA's Max Wave project was studying rogue waves when they found evidence of rogue holes. After that, researchers even recreated rogue holes in a large water tank to study them safely. And they found out that, apparently, rogue waves and rogue holes come from the same hidden pattern in the ocean. You see, the Max Wave project didn't officially list rogue holes as a separate type of wave, but scientists did notice something unusual in their data. They saw deep drops in the ocean surface appearing together with very large wave peaks. This suggested that rogue holes might exist, but there was not enough evidence to confirm it. To test this idea, a team of researchers at Kyoto University recreated ocean-like waves in a long wave tank, about 50 feet long. It worked like a controlled mini-ocean where scientists could carefully adjust wave size and speed. Inside this tank, they were able to create both giant rogue waves and deep rogue holes. The rogue holes looked like sudden voids in the water, deep dips surrounded by normal-sized waves, like the ocean briefly sank down in one spot. It's similar to a sudden pothole appearing on the road, but filled with moving water instead of asphalt. So imagine normal waves as fast repeating bumps moving across the water. Now imagine a much slower, bigger wave on top of that. It looks like a rolling hill that lifts everything up and down. This bigger wave controls how strong the smaller waves are. If the hill hits a wave right when it's already at its highest point, the wave grows into a huge rogue wave, as if someone stacked one wave on top of another. But if that same hill pushes down when a wave is at its lowest point, it creates a deep hole in the water instead. It's like the ocean suddenly drops beneath your feet. So it's the same process, just timed differently. At times, it creates a giant wall of water, and at other times, it's a sudden dangerous drop. So the results of the experiment matched the mathematical predictions. They proved that those strange wave patterns were not just a theory, but something that can really happen in the ocean. In 2016, scientists compared mathematical models with real ocean measurements and found patterns that match both giant waves and deep holes in nature. Of course, in the real ocean, these shapes are not perfectly smooth like in experiments. The waves often have sharper, uneven edges, like a hill that is steeper on one side than the other. But even with these differences, they still followed the same hidden structure. This confirms that rogue waves and rogue holes are really two kinds of the same ocean event. They're just shaped differently by timing and energy. Meanwhile, we still really don't know the ocean. Most of it is a mystery to us. Less than 1/1000th of the seafloor has been seen up close. Imagine the size of Rhode Island or Luxembourg, hey, pick one. That tiny bit is what we have mapped. Everything else, deep trenches, cracks, caves, massive underwater mountains, remain blurry on our maps. Many phenomena went unexplained for centuries, too. For example, sailors kept reporting enormous waves that suddenly towered over everything else, sometimes more than twice the height of normal waves. Back then, most people thought these reports were exaggerations, like spotting mermaids or a giant squid. But those waves were real. Now, in 1826, Dumont d'Urville, a French naval officer and explorer, sailed the Indian Ocean on the ship Astrolabe. Yeah, it's a bad French accent. He saw waves of at least 80 to 100 feet tall during a violent storm that took the life of a crew member. At that time, scientists thought waves couldn't exceed about 30 feet. So, even though his account sounded unbelievable, D'Urville insisted on recording it. And guess what? Yup, instead of being praised, he was laughed at. Okay, I'll stop. Now, even earlier, in August 1498, during his third voyage to the Americas, Christopher Columbus and his crew heard an enormous roar from the sea and saw a wave rising behind their ships. It was as tall as the masts. The wave lifted the ships higher than anything they had ever experienced, and then dropped them into a massive trough. It was like a roller coaster made of water. Now, modern oceanography has confirmed that such colossal waves do exist. They're like skyscrapers suddenly appearing in the middle of a calm sea. A normal wave might be tall enough to reach the roof of a 2-story house, but a rogue wave can tower like a 10-story building. In 1861, such a wave apparently smashed a lighthouse in Ireland. It shattered lamps and sent debris tumbling down a lighthouse staircase. To do that, the water had to climb a 130-foot cliff and then an additional 85 feet of the lighthouse structure. It's almost as tall as a 20-story building. Rogue waves appear suddenly, often without warning, in the middle of the ocean. These waves form when winds, currents, and smaller waves line up just right, making a single giant wave much taller than the others around it. They aren't tsunamis and aren't caused by earthquakes or volcanoes. Physicists model this using something called the nonlinear Schrödinger equation, but basically, it just explains how the ocean can suddenly make a giant wall of water. On January 1, 1995, the Dropner wave struck an offshore gas platform in the North Sea off Norway. It measured 84 feet. This was the first time a rogue wave was officially recorded, proving those monster waves were real. But scientists still consider them rare. Well, by the year 2000, the European Space Agency's Max Wave project confirmed that rogue waves were more common than anyone thought. Using radar from ESA satellites, scientists studied the global ocean and found many waves exceeding 82 feet. Some of the largest recorded waves even reached 98 feet near Newfoundland. Suddenly, what people used to brush off as sailor stories turned out to be terrifyingly real. On the 17th of November 2020, a weather buoy near Vancouver Island, Canada, recorded a very unusual wave in the Pacific Ocean. The wave reached about 58 feet, while the surrounding waves were only about 20 feet. This made it much larger than normal waves around it. On the 29th of November 2022, a rogue wave hit the cruise ship Viking Polaris near Antarctica. One person lost their life, several others were hurt, and the trip was canceled. On the 18th of September 2023, a large wave hit a beach restaurant in South Africa. 7 people were injured, and one person was swept out to sea but luckily rescued. And on the 20th of January 2024, powerful waves hit a U.S. military site in the Marshall Islands. Buildings were damaged, some areas were flooded, and waves moved far inland, showing how destructive these events can be.
We are on the Sea of Marmara, the exact spot where the massive continents of Europe and Asia meet. It's a vital, beautiful waterway packed with cargo ships on the surface, but dive underneath and you'll find a geographical nightmare lying on the seafloor. Deep underwater, 2 massive slabs of the Earth's crust are violently grinding past each other. This isn't just a minor crack in the dirt, it's a colossal geological fault. A massive complex system of continuous fractures that has been accumulating a devastating amount of energy for decades. We call it the Great North Anatolian Fault. All this energy has to be unleashed someday. And when it happens, it's going to hit one of the most densely populated areas on our planet. Scientists are now in active monitoring mode, especially when it comes to Turkey. This country is sitting on the Anatolian Plate, a small bite of the Earth's crust. Nowadays, it's being literally smashed by the Arabian Plate from the south and the Eurasian Plate from the north. Because it's being squeezed so hard, the only direction it can move is west toward the Aegean Sea, and it actually does this at a speed of about 1 inch per year. In geological terms, that's a high-speed, violent movement. Millions of tons of solid rock grinding against each other deep underground day and night without a single break? Not the best thing to experience. All this endless moving, cracking, and squeezing is what creates the North Anatolian Fault, a 930-mile-long fault line that acts almost exactly like the infamous San Andreas Fault. Yet the difference is striking. While the San Andreas mostly skirts the outer edges of Californian megacities or runs through less dense regions, the fault in Turkey is running right under major industrial hubs and heavily populated urban centers. In February 2023, the smaller sister of it, the East Anatolian Fault, showed us how dangerous this tectonic setup can be. It generated the most catastrophic earthquake recorded in Turkey in over 60 years, a brutal 7.8 monster hit and a 7.5 shockwave followed right behind it just hours later. The release of energy was so violent that the ground literally moved by almost 10 feet in some places. Entire cities were leveled and the physical map of the region permanently shifted. Now the worst part, it wasn't even the grand finale. There's no way to stop that energy packed inside the North Anatolian faults. Look at the old data and you'll see it acts like clockwork, a bit like a line of falling dominoes. Scientists have been tracking every sequence of earthquakes in this region for nearly a century. The whole chain reaction started in 1939 with the catastrophic Erzincan earthquake. A massive magnitude 7.8 struck eastern Turkey. It didn't simply release the energy, but also transferred this tectonic stress into the next section of the fault. Dominoes started falling. Other fault rupture happened in 1942, 1943, and 1944. It went west and struck again in 1957 and 1967. Year by year, the epicenters of these massive earthquakes moved in a straight line toward the Sea of Marmara. The last major impact was the Izmit earthquake in 1999. A magnitude 7.6 tremor struck east of Istanbul and lasted for 37 terrifying seconds. Suddenly, the chain reaction took a break, but the tectonic stress was still there, simply transferred to the next section of the fault, under the Sea of Marmara, where the last major earthquake took place in 1766. Nobody had seismographs back then, but historical records and old journals describe it as a scene of unimaginable horror. Now, modern science tells us exactly why it was so devastating. Scientists are calling it a seismic gap, basically a dangerously quiet zone that hasn't ruptured yet. Back then, 260 years ago, a massive quake destroyed a huge part of Istanbul and generated a tsunami that crashed into the city's ports. After this tragedy, it didn't happen again on this scale, but we have to remember that the Anatolian plate has never stopped moving west, an inch a year. Let's do some quick math. That land should have moved by over 19 feet by now, but because those rocks are locked together, they haven't moved an inch. We are looking at a massive backlog of tectonic tension. It simply has to snap finally, and it won't make a regular shake. It will likely rapidly release 2.5 centuries of accumulated tectonic energy, right at the doorstep of Europe and Asia. The target is the city of Istanbul once again. We should call it a supercity because this global megahub is home to an astonishing 15 million people. It accounts for nearly 30% of Turkey's entire economic output. What about the infrastructure? We're talking about 1 million buildings, and an estimated 90,000 of those are at high risk of total collapse in the event of a magnitude 7.5 earthquake. Nowadays, the city has very strict laws for modern buildings. But plenty of urban areas had been built before those regulations were enforced. To make matters worse, many coastal neighborhoods are built on soft, waterlogged soil that acts like a liquid during extreme shaking, multiplying the danger for the residents. Buildings could just sink into quicksand. And there's more. The seafloor of the Marmara Sea isn't flat. There are 3 massive deep underwater holes separated by vast ridges. Why is it important? A stronger earthquake in this area will probably trigger a massive submarine landslide. Plenty of mud and rock collapsing down those underwater canyons would instantly displace massive amounts of water. This would trigger a tsunami, not as tall as mega tsunamis in the open Pacific Ocean, but still highly dangerous. It's estimated that with a 10-foot wall of water, it will be extremely dangerous for this densely populated area. Scientists also claim that it could hit the coastline within 10 minutes. There would be almost no time for a mass evacuation. Here comes modern technology. Engineers are fully aware that this geographical clock is ticking and are fighting back. Essentially, infrastructure is being heavily retrofitted. Also, The mighty bridges crossing the Bosphorus Strait have been reinforced with seismic dampers to absorb extreme shocks. One of the world's largest seismically isolated buildings is located at Sabiha Gökçen International Airport in Istanbul. It's sitting on massive bearings made out of rubber and steel. The absolute art of engineering is the Marmara Tunnel, a massive railway tube that runs directly under the Bosphorus Strait, physically connecting the European and Asian continents underwater. It was built right next to an active fault line, so it had to be designed with flexible earthquake-proof joints. If a megaquake hits and the continents shift, the tunnel will bend and flex like a giant snake rather than snapping in half. Another concern of scientists is the economic aftershock of this rupture. It may affect the entire globe, as the Bosphorus Strait is one of the world's most critical maritime choke points. Every single year, nearly 50,000 ships pass through this narrow waterway, carrying everything that is crucial for the global market: barrels of oil, agricultural goods, and so on. The price of energy and food would go crazy if this shipping line collapses. To buy some precious time, scientists have installed an advanced early warning network on the seafloor of the Marmara Sea. Fiber optic cables and seismometers are constantly listening to the fault. But because the epicenter is located so incredibly close to the city, even this multi-million-dollar system won't give residents enough time to escape. At best, it will provide a maximum of 5 to 7 seconds of warning before the destructive waves hit the city. 5 seconds to shut down gas lines, halt the trains, and brace for the impact. Of course, all this effort won't protect the whole city. Only a fraction will survive. The undeniable conclusion is that the migration of earthquakes isn't just a theory, but a well-documented geographical reality. Scientists estimate that there is a 65% probability of a magnitude 7 or greater earthquake striking the Sea of Marmara region before the year 2030. Now we can see that the rupture in this area isn't just a possibility. It is coming, and it is migrating directly toward the collision point of 2 continents. Right now, as you're watching this video, 28 major US cities are sinking. You might be in one of them, but please don't panic. This process is very slow, progressing at just a few millimeters per year. But why does almost nobody speak about it? When did all this begin? How does it affect large buildings? Why is this happening, and how can it be fixed? Let's find out. Researchers at Virginia Tech conducted a large-scale geological study of the ground and discovered land subsidence. This means that cities like New York, Dallas, Seattle, and others are slowly sinking into the ground. The main issue is that these cities contain a huge amount of infrastructure. If a lamppost sinks into the ground at a rate of 3 millimeters per year, that's not a big deal. But if a skyscraper with a complex engineering structure starts sinking, it becomes a serious threat. The problem is made worse because the ground sinks unevenly. One part of a city may sink faster than another. The same applies to buildings. If the left side of a house sinks while the right side stays in place, the entire structure could collapse. The problem also affects roads. Vertical land motion can cause cracks and even complete failure. A similar situation is currently happening in Jakarta, the capital of Indonesia. Land subsidence there is so severe that the country is actually relocating its capital to another location. Experts predict that by 2050, 95% of North Jakarta will be completely submerged. Right now, some areas are sinking at a rate of about 10 inches per year, and half of the city is already below sea level. The walls of houses are covered with cracks, the streets smell of dampness, and people who remain in the city are constantly repairing their homes. Yet despite this, luxury real estate continues to be built, and people continue to buy it. Many residents have grown accustomed to these conditions. Flooding has become part of their daily routine. But how do they plan to solve this problem? Authorities want to build a dam, although many experts doubt it will help. It's hard to imagine a similar situation in New York, a city where nearly 26% of the US population lives. The ground beneath this metropolis is sinking at a rate of about 2.5 millimeters per year. That's about 1 inch in every 10 years or 5 inches in 50 years. You might think that's slow to worry about, but the problem is that the ground has already been sinking for decades, and it's almost impossible to predict at what point serious infrastructure problems could begin. But beyond New York, the threat also hangs over Houston, Texas. There, the city is sinking at a rate of just over 5 millimeters per year, which is twice as fast as New York. Fort Worth is sinking at about 4.5 millimeters per year. Dallas is at nearly 5 millimeters. Chicago is sinking at just over 2 millimeters per year. Denver at 1.7 millimeters per year. New York at nearly 2.5 millimeters over the same period. You can find the full list of cities with the most widespread subsidence on the internet. According to scientists, in all 28 cities, at least 20% of urban areas are sinking. In 25 cities, 65% of the ground in inhabited areas is subsiding. If percentages don't mean much to you, here's a number. More than 29,000 buildings are located in zones of high or very high risk of damage. And with each passing year, the risk increases. Some of the highest rates of subsidence are being recorded in several Texas cities, where the average sinking rate is about 5 millimeters per year. Houston has turned out to be the fastest sinking. About 42% of its territory is sinking faster than 5 millimeters per year, and 12% faster than 10 millimeters. New York is also facing serious issues. At one of the city's 3 major airports, LaGuardia, the ground is subsiding at a rate of more than 5 millimeters per year. But the biggest problems are in California. In some areas of this state, the ground hasn't sunk by millimeters or even inches, but by nearly 30 feet. That's about the height of a 3-story building. What does this lead to? Large depressions in the landscape and a wide range of infrastructure problems. Authorities need to figure out how to preserve the integrity of buildings, roads, and bridges before the situation reaches a point of no return. But how can this even be stopped? The solution lies in the very cause of the problem. There are too many people, and buildings have become too heavy. The ground is giving way under all that weight. And okay, that was a joke. The real problem is water. Tens of millions of people live in major cities. And where do you think authorities get the water to supply them? Especially when there's no nearby lake or river with fresh water. They take it from underground sources. And every year, as the population grows, the amount of water extracted grows as well. People are essentially draining underground water reserves, and this leads to serious land subsidence. This issue is especially severe in California, where groundwater is extracted for agriculture. The situation is made worse by hot weather. Lack of rain and drought destroy crops. So where does the water for irrigation come from? Authorities rely on underground sources. Let's return to Jakarta for a moment. Some experts believe that completely stopping the use of groundwater could save the city from flooding. This would require residents to switch to other water sources. Otherwise, the city may have no other options left. In the United States, there are additional challenges. Alongside heat that damages crops, there are opposite extremes. Heavy rainfall leads to the deformation and collapse of infrastructure. Strong winds and hurricanes can cause severe damage to buildings and roads. In addition to groundwater depletion and changing weather patterns, there is another factor. Yes, you're probably tired of hearing that things are getting worse, but no one said this would be easy. Tectonic activity is not uncommon on the West Coast. The ground is sinking, and deep underground tremors further destabilize it. On top of that, coastal cities like Los Angeles, San Diego, San Francisco, and others are suffering from rising sea levels. So, here's what we have. Underground, the soil is sinking, and earthquakes are occurring. On the surface, extreme weather is destroying cities and rising sea levels are flooding coastal areas. The situation may seem hopeless, but of course, there is a way forward. Let's not get into the issue of global climate change right now. Many scientists have already proposed countless ways to reduce its impact. Right now, authorities need to focus on the issue of groundwater extraction. One solution may seem unpleasant: wastewater recycling. We use water to take showers or flush toilets, and then it goes down the drain. Scientists want to collect and treat this water so it can be reused. It may sound unappealing, but modern filtration technologies can clean water extremely well and make it safe for reuse. This approach could significantly reduce groundwater consumption, although many people may resist it. Another method is rainwater harvesting. Scientists suggest creating special green zones in cities that absorb rainwater, collect it in large reservoirs, and send it back underground. Geologists might be able to identify the most depleted areas and inject rainwater into them, like filling an empty bottle. And what if every resident placed large containers outside their windows to collect rainwater during storms? Recycling wastewater and harvesting rainwater could reduce pressure on underground sources. It's possible that the process of land subsidence could slow down or even stop. But there is another problem. Humanity will continue to increase its water consumption because of artificial intelligence. Already, massive amounts of water are being used by large companies to cool data centers that train AI models. Every year, they consume more and more, but that's a topic for another video.
In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid, called 2024 YR4, had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth. Well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there is a very large uncertainty range, about plus or minus 46,000 miles. So it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see